Hi everyone, here's your introduction to lab number 5, our chapter 4 lab. The name of this thing is pretty funky. It's the Quince-Uncs. Never mind why that's the name. Here's what it's all about. So in the 1870s, this guy Sir Francis Galton created this device that he called the Quince-Uncs. So it's a vertical board with a bunch of pegs on it. And you see this picture here. So all these pegs like direct the path of a marble. So you see this marble bouncing through. The pegs force the marbles to randomly change direction. So imagine one marble coming down and it's going to hit that first peg. And the idea is it has to either bounce to the left or to the right. And then when it gets down to the next level, like the next row of pegs here, let's say it bounces left, then it's going to hit this peg and it might either bounce to the left or to the right. And if you follow this path, let's say it bounces left again, then it hits this peg on the third level, the third row, well, it can either go left or right, okay? So every time it gets to the next row, it has a choice. Does it bounce left or does it bounce right? So the idea is by the time it gets to the bottom, there's all these bins. And in this particular graph, the bins, you always begin by labeling them with bin 0, then bin 1, bin 2, bin 3. This one has up to 7. So there's really 8 bins, but you start at bin 0, 0 through 7. And the guy's idea, Galton, he wanted to study how these marbles end up getting distributed at the bottom of this Quince-Uncs. It turns out, as you might suspect, most of the marbles go towards the center, and only very fewer and fewer marbles end up towards the outsides. Okay, so what are you going to do with this? We're going to start by just playing around with the Quince-Uncs. So there's an interactive simulator here at this website, Math is Fun. So take that web address, go there. I have it brought up here in mine, so I'll just pretend like I'm typing that in for the first time. And this is what you'll see. So here is this virtual Quince-Uncs, and so it starts, and you see a bunch of marbles bouncing all at once. And every time they hit the next row of pegs, right, they either have the choice of bouncing to the left or to the right. This particular one that it starts off with, it's got a size of 6, so that means there are 6 rows of pegs. Let's count them: 1, 2, 3, 4, 5, 6. And the bins are labeled 0 through 6. But we can change this stuff around. We can make, a size 10. If I hit restart, it makes it bigger. Now there's 10 rows. We can make it smaller. We can change the percentages. So initially it's 50-50, meaning 50% chance bouncing left, 50% chance bouncing right. But you can adjust that. Let's put it more toward the right side. Then they're more likely to bounce right. Only every once in a while, right? Like here, 19% chance of bouncing left. Or we can drag it back this way, and now they're mostly going to bounce left. You just kind of play with it. And then the speed is really nice. You can speed this thing up so the marbles bounce faster. And what's pretty cool is it counts your marbles here at the bottom. Let's put it back to 50-50 and then restart. So it will, let's make this thing a little bit smaller, maybe like 4. There you go. So it'll count how many marbles land in each bin, which is pretty sweet. Or, you can slow it way down if you prefer. You can pause, that sort of thing, and it won't release any more marbles. Okay, so the idea is you're going to just kind of play around with that, and I've got some questions there for you. When you get to number 2, now here's when we start using, start really getting into how this connects to the discrete random variable and probability. So number 2, you're still using the simulator. Create a Quince-Uncs with 8 rows of pegs and a 50% chance of bouncing left and a 50% chance of bouncing to the right. So we'll go back. We're making, doing 8 rows of pegs, and let's restart this. Let's make it go a little bit faster. And what it's asking us in part A, click restart and let exactly 20 marbles fall. Let me go back. How many do I have? Okay, so the idea is as soon as it hits 20, you're going to click pause. and then those marbles will keep bouncing. So pause right there, and now I've got exactly 20 marbles falling. And okay, so what I would do, say, okay, I did this simulation, right? All the, the speed doesn't matter, but I got the other things set up right. I let exactly 20 of them fall. We're going to convert the number of marbles in each bin to a probability. So I had none here in 0 or 1, but I had 2 there in bin 2, 4 there in bin 3, and okay, you see what I've got. I'm going to convert those to a probability and then fill these in. So a probability would mean I take the number of marbles and divide it by the total number of marbles, which in this case would be the 20. So to fill in these probabilities, well, bin 0 and 1 would be 0, but then here for bin number 2, I'd say, well, there were 2 marbles, right, divided by 20, which in this case would be exactly 0.1, 10%. So I would put 0.1 or 0.10 or something like that. Round to 3 decimal places if you need to round, and fill out all of your bins there for that experiment. Okay, now you're going to start again, but now simulate 100 marbles. So you would go back, and you could just pick it up where you started. You could go with these, or you could restart it from the beginning. You're going to let 100 marbles fall. I won't go through it all, but if you maximize the speed, it won't take long. Just be sure you slow it down when it gets near 100 so you can pause it at exactly 100. And it'll be similar. You'll fill in those probabilities, right? Divide the number of marbles by 100. Finally, you're going to do it with 500 marbles. And you're going to fill in the probabilities. Then I've got a question there, so think about that. Okay, then we get to number 3, and this is where it really gets interesting. So it turns out that the Quince-UNCS models a binomial distribution, and this blows us away. How does this machine or a device, whatever you call it, how does it model the binomial distribution? Okay, so a lot of students get tripped up in exactly how. So let me kind of talk you through what I've got written here. So typically many marbles are dropped, but just consider 1 marble. Okay, and this is where a lot of people get tripped up. So if we go back to the simulator, I'll just pause it here. So, we let a lot of marbles fall in our simulations. So it could be easy to think it's the number of marbles that are falling that somehow is connected to the binomial distribution, but that's not the case. Let me go back here. Just think about 1 marble as it makes its way down, okay? So if you remember a binomial distribution, right, there's a fixed number of trials, and the results of those trials are either a success or a failure. So how does that connect? Each trial occurs when a marble strikes a peg and must bounce either left or right. Okay, so let me just release one more here. So think about just 1 marble falling, and every time it hits a peg, it's now going to experience a trial. Does it bounce left or does it bounce right? We do let, in the simulations, a lot of marbles fall, but the number of marbles is not the number of trials. Every time 1 marble drops, it goes through several trials, and it depends on the number of rows of pegs, right? So here it goes through a trial when it hits peg number 1. Does it go to the left or does it go to the right? Then when it hits the second peg in the second row, does it go left or does it go right? If there are 8 rows of pegs, well, that would tell you how many trials each single marble would experience, and then we'll of course end up in one of the bins. We're going to say success is when the marble bounces to the right. Okay, so let's release just one again. So there it went to the left, so we'd call that a failure. There it went to the right, that's a success. There's a failure. There's another failure. There's a success. It's not like success isn't better than failure here, it's just the way we name it. Okay, so that's kind of bizarre. So that actually explains how we label the bins at the bottom and why we start with 0. This means that the bin values of 0, 1, 2, etc., depending on how big your Quince-UNCS is, are the number of successes a marble experiences. For instance, bin 0 tells us the marble had 0 successes since it bounced to the left every time. Think about that. If a marble bounces left every time, then we would say that is 0 successes, and guess what? It lands in bin 0. If it has exactly 1 success, it bounces to the right once, but to the left every other time, guess where it's going to land? In bin number 1. And it wouldn't matter when that success happened, right? It could bounce to the right on the first one, or it could bounce to the right on the very last one, or anywhere in the middle. If it has exactly 1 success, it lands in bin number 1. If it has 8 successes, guess where it's going to land? In bin number 8. And then you kind of see, those in the middle as well. Okay, so I'll have you then explain in detail how it meets all 4 of the binomial requirements with that in mind. Okay, where's this going? So now that we've done all these simulations and we made the connection to the binomial, we can now apply the formula for the binomial distribution to find the theoretical probabilities for this Quincunx. Same Quincunx, 8 rows of pegs. You got the 50-50 chance of bouncing left and right. A success is when the marble bounces to the right. So you'll have to figure out the values of N, P, and Q. That would be plugged into the binomial formula. And then you'll go through and you'll fill in this table for all these different X values. So you'll do the calculation when X equals 0, 0 successes. What's the probability using that binomial formula? Then X equals 1. What's the probability of landing in bin number 1 using the binomial formula? You'll do all of these, bin 0 through 8. And then what's kind of cool is you can compare those theoretical probabilities with your simulated probabilities, and you should see, some connection there. Lastly, number 5, you're going to redo this experiment, but with a smaller Quincunx, and we're going to change up the probabilities. So 5 rows, and we're going to change this to be 80%, 80% to the right. If I can get, there you go, 80-20. So 80% to the right, which would mean 20% to the left. And we will simulate that in a moment. First, you're going to calculate the theoretical probabilities using the binomial formula. Another question here about expected value. And then you're going to do a simulation with 500 marbles for this one. So we need to restart. And we might want to speed that up to do 500 marbles. But okay, you get the idea. And that is your lab. This one really needed a lot more explanation because the students get tripped up in several places on this lab. So hopefully that was thorough. Anything not clear, you can certainly visit office hours either today or on Thursday. And yeah, I will see you guys then, or, shoot me an email if something's confusing too. All right, good luck with that. That's all.